All right, Unit 5 deals with rational exponents and radical functions. We've done some work with square roots already, but we're going to talk about cube roots and fourth roots and fifth roots, etc. The work gets a little intense, and this one's kind of a doozy, but once we get this out of the way, we'll have pretty smooth sailing through the first half of this unit. We will split this one into two parts. We'll do lessons 1, 2, and 4, and then we'll go on to lessons 3 and 5 for part 2. So part 1, we're going to focus on nth roots and radical equations and all kinds of fun stuff. So the learner will be able to relate roots and rational exponents to simplify expressions and to solve equations. And so we have to learn a little bit of vocabulary about roots. So again, the nth root of a number c is x, such that x to the nth power is equal to c. All right, we can write this in radical form as the nth root of c is equal to x. So what this is right here is that this tells us the index, this is the radical, this is the radicand, and this is that root, that nth root of c. So there's some vocabulary there that we want to make sure that we get straight. It's just going to make our conversation about this go a little bit more smoothly. And all of the roots that we're going to explore, we're going to try to focus on real roots in this unit. I know that we have had some imaginary roots or some imaginary solutions when we've just talked about solving polynomial equations. And so let's think a little bit about these two scenarios. So if I want to find the real cube roots for 125, I would say x is the cube root of 125. And the way that we're going to evaluate this or solve this situation is to think about x cubed equaling 125. So what number to the third power is 125? And if we're going to try to process that, we can solve this as an equation, x cubed minus 125 equals 0. And we've solved polynomial equations back in Unit 3, and so we want to do a good job with that. We can solve this as a difference of cubes factored form. And so x cubed minus 5 cubed is going to be x minus 5 times x squared plus, right, the opposite sign there, 5 times x plus 5 squared. And that equals 0. Well, when we worked this back in, or questions like this back in Unit 3, we knew that there was a real solution here, x minus 5 equals 0 when x equals 5. But then for this component, we always saw that it was an imaginary component to this quadratic. All right, those were the other two zeros were imaginary answers. So there's only one real root. So the cube root of 125 is just 5. There's not multiple answers there. When we're talking about even roots, so the real fourth roots of 16, when x equals the fourth root of 16, what are the numbers that are the fourth roots of 16? We want to think about those real roots. And so x to the fourth equals 16, x to the fourth minus 16 equals 0. We can factor that as x squared plus 4 times x squared minus 4 equals 0. And here we know that we can factor that further, but this x squared plus 4 equals 0 will only have two imaginary answers, whereas this will have two real answers. And so we would say the real fourth roots of 16 are positive 2 and negative 2. All right, now when it comes to working with that, we want to also understand that we can use our calculator to try to compute fourth roots. And the struggle with that is making sure that we understand that there's both a positive and a negative fourth root. And so if I want to do the fourth root, I'm going to press math and then go down to where it says x root. That changes the index of our root, the fourth root of 16. It's only going to give us the principal root, which we're going to talk about in a little bit what that is. It's going to give us 2. But we know that negative 2 to the fourth power is going to give us positive 16. And we know that positive 2 to the fourth power is also going to give us 16. So there are two real fourth roots for 16. But there's only one real cube root of 125, all right? Because negative 5, let's do this. Let me show you this. Negative 5, if I would put this in parentheses, negative 5 to the third power is going to give us negative 125, all right? So we can take odd roots of negative numbers, but we can't take even roots of negative numbers because it gives us imaginary output. So we're going to focus on real roots in this unit. So here are a couple things to be aware of. When we have positive roots, when we're taking the roots for a positive number, if we take an even root of a positive number, we are going to have two answers, a positive and a negative. When we take an odd root of a positive number, we're only going to get one answer. It's just going to be positive. When we're taking an even root of 0, there's going to be one answer. When we take an odd root of 0, there is going to be one answer. When we are taking, and it's just going to be 0, right? When we are taking the even root of negative numbers, all right, there are no real roots. No real roots. But when we're taking an odd root of negative numbers, there will be one negative root. All right? So we're only considering these possible real roots. We're not worried about imaginary numbers in this case. So 2, 1, 0, 1, 1, 1. All right? I want to keep that straight. So let's do a little bit of exploration here, and I want us to use the calculators where needed or use our heads where possible. And so we could obviously write that as a fraction, but I'm just going to let our calculator do this work. We're going to do the cube roots of 0.027. So when we go to our math menu, we can see that there is a cube root button that sort of shortcuts us from having to type 3 and then x root, but we can do the cube root of 0.027, and we will have one answer, 0.3. So we're going to use our calculator to say the cube root of 0.027 is 0.3. Another way for us to do that would be to write that as a fraction and take the cube root of the numerator and the cube root of the denominator. That's always a fun time, and I'd love for you to explore that. When we want to find the real fourth roots of 625, we are going to use calculator and say the 4 math 5 here to get the x root. And we're going to do the fourth root of 625. It's only going to give us a positive number, but we know that negative 5 will also be an answer. The fourth roots of 625, we want the positive and the negative, is going to give us positive and negative 5 as our answer. All right? For this, the fifth roots of negative 32, if you're using your calculator, you're going to get an output of negative 2. The real sixth roots of negative 64, the sixth roots of negative 64, are there positive and negative? Oh, this is a negative number? There are no real roots because we have a negative radicand, no real roots for the sixth roots of negative 64. All right, moving on. Letters E and F, I want for you to try to do those. I would like for you to try to do those. We have one that's written as a fraction. Be very careful with that. And then we have 0 in there. Try to find the real fourth roots of 0. You can probably answer that one pretty quick. All right. Now, considering the principal root, that's what we did with our calculator just a moment ago. The principal root is a situation where we're only going to focus on the positive root if we're talking about an even index. All right? So when a number has 2 real roots, when it's an even index, then we say the positive root is referred to as the principal root. Right? That's what we care about. A lot of times with some of the work that we do with square rooting or fourth rooting or sixth rooting, we really only care about the principal root. If a number has only one real root, then that root is automatically also the principal root. So it's not always just a positive answer. We can have negative answers on these situations. So let's have a little exploration. When, like, this symbol right here just means 5. The square root of 25, there are 2 real roots of 25, 2 real square roots of 25, but when we use that symbol, that refers to only and exclusively the principal or positive, in this case, square root. When we talk about cube roots, however, and other odd roots, we want to make sure that we understand that the cube root of negative 27 is negative 3. The sixth root of 729, it better be 3 or else I'm off my rocker. But let's do the sixth root, the even root there for 729. Okay, good. Thank goodness. It is 3. Thought I lost my cool for a moment there. Want to make sure that we have the sixth root of 729 written in this form is just 3, although the real sixth roots of 729 would be both positive 3 and negative 3. Fourth root of negative 16, no real solution. All right, it does not exist. All right, because this would have to focus on imaginary numbers, and we're only going to focus on real numbers at this juncture. All right, so now what I want for us to consider is how we can simplify radical expressions. And so this might go back to Algebra 1, Lesson 1, where you simplified square roots even before you started doing a lot of operations with radicals. And what we want to make sure that we understand is when we take the nth root of a number or a variable to the nth power, we want to make sure that we consider the absolute value of that thing. Now, you're going to write this down, and this is a little bit silly to be attentive to absolute value versus not. In Algebra 1, you didn't pay attention to that. Here in Algebra 2, we're going to talk about it, and then we might just kind of move on with our lives, but we want to be able to simplify some of these expressions in radical form, taking those radicals where appropriate to simplify our radicals, finding perfect cubes or perfect fourths or whatever. But if we ever take the nth root where we have an even power, we've got to understand that this has a constraint in our domain, right? We can't take the nth root of negative numbers, or we can't take an nth root and have the output be negative. So we want to make sure that we are attentive to the fact that that must be positive. And so if that variable happens to be negative, we will always take its absolute value. If it's an odd index and an odd power, then it doesn't actually matter. So don't worry on that. So in this case, we know that the principal square root of 9 is 3. And the square root of x to the 10th, right, if we have x to the 5th squared, that's going to be x to the 10th. And so we are going to end up with x to the 5th here. Now the issue here is if x is a negative number, then this is problematic. So we want to put this in absolute value. All right? Now there's a couple ways to write that. You can either put x to the 5th in absolute value, or you could put x in the absolute value and put the 5th on the outside. Either way, to me, is acceptable. But generally what we're going to do is we're going to have this phrase where it says assume variables are positive. And so if we assume that the variables are positive, then our answer here is just going to be 3x to the 5th. All right? So this is one way to write it, this is another, and this is a final way to write it. But this is only if we assume that the variables are positive. Over here we are doing an odd root, so we don't have to worry about the fact that the cube root of x cubed is going to be x, and the cube root of y to the 6th can break down as the cube root of y cubed and the cube root of y cubed. All right, the cube root of y cubed is y, the cube root of y cubed is y, and then we have x, and so we get x, y squared. You might discern that there's probably some shortcutting that we can take with this, and I'd love for you to create that understanding in there if we don't get to it by the end of our lesson. Over here, let's keep working here. We've got the 4th root of x to the 16th. So we have the 4th root of x to the 4th, and x to the 4th, and x to the 4th, and x to the 4th. That's a total of 16. And then we have the 4th root of y to the 4th. And so when we do that, we get x, and x, and x, and x, and y. But we are ending up with an odd power now, so we need to say that's the absolute value, and the absolute value, and the absolute value, and the absolute value, and the absolute value, or the absolute value of x to the 4th y. Now here, there might be a way to think about that as, well, no matter if x is positive or negative, when we do that negative number, if it's negative to the 4th, it's going to end up positive anyway. So we only need to put the absolute value around the y value, unless we assume that the variables, sorry for the handwriting, are positive. Then we can just say that this is x to the 4th y. All right? Now, I want you to write kind of both of these situations. I want you to understand this. I want you to be able to get that. On the right side here with letter D, we have the cube root of a negative 8, cube root of x cubed, cube root of y to the 9th. And hopefully you're figuring out now that this is going to be negative 2, that's going to be x, and this is going to be y cubed. And we would write that all at once, like so. You can write it like this, but this is the better answer. All right? Just a better way to write it as one monomial, right? I would love for you to try to do these. You might need to use your calculator to do the 5th root of 32. I think that I've already done that once, but maybe not. Maybe I didn't do that already. And then I want for you to try this one. Make sure that you include your absolute values as part of your answer, and then one where you're assuming that the variables are positive. All right, pausing if needed. This is kind of wrapping it up, right? So I know that this video is already a little bit long. We're probably going to be about 4 or 5 more minutes. Here we're going to be solving equations. And we solve equations by performing inverse operations. So when we do evaluating, we do PEMDAS or GEMDAS or however your Algebra 1 and pre-algebra teacher showed you. But when we're solving, we work those in reverse, right? So we're going to start with dividing by 2, and then we're going to take our 5th root. Do not take your root first. You have to get rid of your coefficients. And so when I divide both sides by 2, I get this. And then x is going to be the 5th root of 32, all right? Now the 5th root of 32, we know is only 2. And so we can always check our answer to make sure that 2 times 2 to the 5th power is equal to 64, and in fact it is. Over here, x to the 4th is going to equal, divide both sides by 2 here, we get x to the 4th is equal to 81. So that means that x is equal to the 4th root of 81. You can use your calculator to break that down. The 4th root of 81 is going to be 3. So again, we're just using the radical form to undo the exponentiation, right? We're going to use radicals to undo exponentiation. Let's do some that have a little bit more teeth to them, and let's see if we can still navigate the Algebra 1 process with this Algebra 2 idea. So here, this is grouped already, so I don't have anything added or subtracted on the outside. That means I'm going to take the cube root on both sides. The cube root of 729 is 9. And so now I can subtract 2 from both sides and get 7. Want to make sure that you are comfortable with that you can do that work to find these cube roots and 4th roots, and in this case, 6th root. So here we've got 7 being added on the outside, so we're going to have to subtract 7 from both sides. 1, 1, 7, 6, 4, 9. Ugh. So let's see if we can take the 6th root of that long, crazy number. Now, this is not something that you need to know in your brain, but you need to know how to do it in your calculator. So we are going to do the 6th root of 117,649, and I get, using my calculator, I get 7. All right, hopefully you know how to type that onto your calculator. And so I get x minus 1 is equal to 7, and that means that x is equal to 8. But here we have a little problem, right? Because if I look back over these, this was an this was an odd index. This was an even power. So an odd power, so odd index. Even power, even index. Well, I guess this is a different example. Odd power, even power. So when we take these roots, we have to be careful. Are there positive and negative roots? Uh-oh. So we have to be aware of a couple things. This has a -7 as a possible answer there. All right? So we know that for one of these answers, we'll have x minus 1 equals -7, x minus 1 equals +7. We've got to consider that when we take our roots for even indices, that we need to have a positive and a negative root. So we're going to have to go back and fix what we did on the last slide, because we're going to get 2 answers. Now the question is, does this work? All right, let's check the -6 to see if it works. All right, so we know that if I take -6 minus 1 and I take it to the 6th power, it should give me this number, which then I add 7, and it gives me 117,656, which is what we started with. So -6 does satisfy this equation. Oh man, Mr. Hibbett, you messed me up. So what I want for you to do is I want you to go back to letter B here, where we found that x was equal to 3, and realize that x could be also -3. All right, so you want to correct that on letter B. For this last little part, all right? I know you're like, oh, how can there be more? But we have just a lot of concepts to kind of tie together. And this is kind of like the icing on the cake or the bow on the present here. Consider this lesson a gift. What we have here is writing a radical as an exponent, all right? Taking a radical and writing it in exponential form. The index can be written as the denominator of the power, all right? So here's what I mean by this. So the nth root of a is a to the 1 over nth power, all right? Maybe the font here is a little bit funny, but what this should say is a to the 1 over n is the exponent, all right? So 1 over n is just the exponent to this base. If you have a exponent in the radical, then we can write that as a to the m, but then over nth power. All right, this is a little bit fun to explore, and we're going to have to review some properties of exponents next time that we're together. But we want to make sure that we can connect the dots between the index, the root, the power, the radical, and how these are all combined together. So, in this case, writing radicals as exponents, we're going to write this as x to the 3rd over 4, right? X to the 3/4. We're going to write this as x to the power denominator. This is this whole thing, but with a square root, that's the 1/2 power. We'll talk about how to simplify that in another time. And then this here, I would like for you to try to write that in an exponential form. Try to write that as an exponential form. Writing that in the reverse, given the exponential form, can we write it in radical form? So this would be the cube root of 64, which we know is 4. This would be the 7th root of x squared. This would be x to the 5/2. 2.5 is 5 over 2, which means that we have the square root of x to the 5th. You can also write that as the square root of x to the 5th, all right? I'm a bigger fan of this. And then here, this is 32 times the 5th root of x cubed. You have to be aware that this is not in parentheses, but that's what you're going to get to do on letter F. This is 32 times this power, and so I want you to write it like that. All right? You try letter C and F, and then we will discuss it in class. All right? That is, and pause it as needed so you can do that, but that is the end of the lesson. Hopefully you can relate our roots to our exponential forms and connect those dots to evaluate algebraic expressions involving radicals.